Hi everyone, welcome to this session by FreeSoft. I am Vladimir, acting as a Service Delivery Manager. Our session for today is going to be about ADABAS and natural conversions to the Couchbase and Java platform. This is the agenda for today. I've just collected a couple of slides for you, starting with a short introduction on our approach and who we are. I would also provide a bit of background information on our tools and methodology, how we approach this whole legacy modernization topic. After that, I'm going to dive through our demonstration for real-life migration of a few ADABAS datasets from the mainframe platform to the open system Couchbase database. At the end, I would just mention shortly about different aspects of our other activities in the project, which is, in addition to the database migration, the conversion of certain applications and testing them on the open system. These legacy applications that we are talking about today are 20, 30 years old applications. Usually they are huge and complex, especially on the mainframe. So we believe that there should be tools behind if someone tries to modernize or migrate them. Here in FreeSoft, in the last 15 years, we have developed a framework for automated parsing and conversion of different legacy applications like ADABAS Natural, PL1, COBOL, or even TIBCO's Object Star, for instance. Our business model is to provide services instead of tools because we believe this is the key to success, to combine these special tools, highly automated tools, with the expertise, how to use those tools and how to implement these projects. So we are a service company and we don't usually sell any kind of legacy modernization tools. The automated tools that we use in our projects are called the Liberator Workbench. This is a framework technically containing more than 200 different development projects in Java that we have in-house. It's unified in terms of the fact that whatever legacy system we parse and convert with it, either COBOL or ADABAS Natural or PL1, at least 80% of the implementation is the same. So we use the same parser engine, we use the same code converters, generators, revokers, and dispatchers. And the difference in the case of the different legacy programming languages and databases is practically the language plugin that we have to develop for each and every legacy. So it's unified, and generally it contains 4 different big tools. The first one is called Knowledge Liberator. This is the parser engine, a high-performance language processor that's capable for reading up different source code elements, data definitions, and any kind of programming objects from source code, and create different repositories from them. As a second step, it converts these objects into intermediate code models, which are practically more or less independent from the programming language. It's very efficient because this is going to be the input for the rest of the processes and for the other tools in the migration project. Knowledge Liberator also has a GUI that runs in the web browser. It's a viewer application for seeing the meta information and analytical information for the legacy system. It has inventory metrics and cross-reference reports, and it allows the export of any sort of information from its repository through this interface. And the next tool is called Data Liberator. This is the one that we use for database migrations. It's responsible for converting data schema. For instance, in our case today, we will see that it picks up ADABAS schema from the mainframe and converts it into something else. And Data Liberator is capable for migrating into relational models, so it has a capability for normalization of the data schema, or it can just straightforward load it into an NoSQL database like Couchbase. Besides this, it's also an ETL tool, so extract, transform, load tool. Mainly transform and load, because in the case of the mainframe, usually the input is coming from a mainframe utility. So there's no need for extract because with some standard mainframe utilities, it has been already exported at that point. So in addition to the schema conversion, it does this whole migration of the data set to an open system data set. It contains fcdig to ASCII and other data conversions. The biggest part of the framework, the Liberator Verbash framework, is the code liberator. That's the one that's creating Java code from the legacy application. What it creates is a compilable application, so you can send it to a deploy and build process. So practically each and every component is generated for a Java application that's needed for a complete batch or online application. In the online mode, you can deploy it in an application server. In batch, you can just use some file-level jars, or you can put them into containers. The last tool that supports the project itself, it's called AppTester. AppTester is a test automation tool because, as we will see in the next slide, we have many iterations in a project like that if we use this highly automated process. AppTester is capable for recording test cases in the mainframe application, storing them, and replaying them in the Java. After this replay, it will verify the output, either in online or in batch mode, and it will report it whether passed or not. So practically, this is a very efficient tool for reducing the testing effort in the legacy modernization project. Testing in this project, of course, means that the migrated converted application should work and behave identical to the legacy application in the new environment. Besides having the right tools and highly automated processes in the project, it's also a key factor to have a proven and right methodology to use those tools and processes during the conversion and the migration. The FreeSoft methodology is relying on iterative cycles that you see on the middle of the screen, practically containing 5 steps. The first 3 is deeply technical: parsing, conversion, and build. This is where we prepare the new application and new database after migrating it from the legacy platform to the new. The next step is testing. This is the comparison between the legacy and the converted one running in the new world. And the fixing, this is the most important thing, that we don't start fixing any migrated or converted component. We believe that this process should be still automated, and at that point there should be no human intervention in the code and in the database. So whenever something is wrong, we try to fix it in the conversion process itself and then repeat the whole process again. In this next iteration, the quality should be higher than before. We repeat this cycle as long as the migrated database and application does not pass the predefined success criteria, and only at that point we think that the project should go into the user acceptance phase. So we have arrived to the demonstration part. In the next few minutes, I will be connecting to a Linux machine that's running the Couchbase server, and I will migrate some mainframe ADABAS datasets to the Couchbase database. So as a first step, we need to configure our DB migration tool a little bit. What you see on the screen is our toolkit for configuring the data liberator tool. There are a couple of things that are important to set for the DB migration tool, the data liberator, when we are processing mainframe files. We will have to set the library definitions, the ETL config, and the DB config. Library definitions will tell what kind of input we are using. At the moment, in this case, we will use physical definitions from the ADABAS database and logical definitions from the natural. These are the 2 inputs that we need in order to potentially load data in a proper schema in the open system, the Couchbase. So without converting natural code at the moment, we just need these 2. Otherwise, we would need an additional library for natural objects. The second thing that we have to set is the destination database parameters. We have to set here the Couchbase engine and the access to the to the database itself. The DB server port, query port, admin user, the user password, and things like that. The last thing that we have to check is the ETL configuration. There should be a source code page and destination code page that we are processing, if there are separator characters in the data or not, and something which is more specific to the ADABAS and the mainframe. In this case, the unload file format should be, in our case, the ADABAS decompress. The ADABAS compress. So what we have is binary compressed data from the mainframe. This is what we will process today. Two processors we have to still set. We define what to do with the schema and what to do with the transform and load process. We have to set it to create schema for the schema itself, and we have to set it to that create load. It will create dot files, so data files that are holding already ASCII converted data, and then it will load them into the engine itself. We could choose the pipe load as well. It's a bit faster, but I just want to show you what happens in details when we choose this option. So we can quit this tool and go to a SSH terminal. So we will connect to a Linux machine and start the loading process with the pre-configured tool. Let's check first briefly the environment that I have prepared for today's demonstration. First of all, we have here the Couchbase server, just one node running on a Linux machine here in-house in the FreeSoft office. I have prepared just one bucket called Convertjar demo. You can see it's practically empty. There's nothing inside except for one index is created, primary key, but obviously it's not done yet, it's just there. The other thing that I have here is the SSH terminal for the same Linux machine. So I'm going to load the data from the local host. What you see is the working directory called database conversion. Most interesting for us will be the etc library. The libs library just containing the data liberator tool itself. So the tool is deployed in this environment at the moment, and what we have to run is the Convertjar script. It will simply launch. You can see that it just simply launched the NoSQL conversion jar within the libs library. This is the starter program for the tool. All right, so let's check the content of the etc library. The first and most important directory that we are going to check is the source directory. If you remember, for the configuration, we defined two libraries for the tool itself, the DDM and the FDT libraries. FDT stands for the physical definitions, the field description tables. It's a report from the ADABAS engine on the mainframe. If we just open it, we can see that it's not really user-friendly, but if you are familiar with ADABAS, then you will understand. This is how it looks, just very short two-character identifiers for the physical definitions in the ADABAS files. The next one, the DDM, this is the natural logical view, also input from the mainframe, also definition. It's the logical view of the same data, and we will use this to associate naming information to the physical definitions. The third one, the extract directory, holds the business data itself unloaded from the mainframe with the ADABAS utility. Currently, we have this in a compressed format. So it was exported with the ADA-ULD, the ADABAS unload utility. If you just go inside, you can see we have 5 files altogether, more than, or a little bit less than, as I see, less than 1 gigabyte of data. If you just look inside, you can see that this is the FCD coming from the mainframe, and it's also compressed. So there should be a transform process to get real data out from it for our loading purpose. So that was the source directory. The other interesting directory is the configuration. That holds a couple of files. Most of them, some of them is XML, some of them is a CSV. It can be important if you want to further configure and customize your process. For instance, if you have more logical definitions than you want, you can simply exclude some of those with that single CSV. Or if you have more physical definitions in the file, then you can also just ignore some of them. And other comfortability features like that. So this is the directory that we have currently, and what we are going to do now, I will run the convert process, and we will see that the data is read out from the definitions and also from the unknown file, transformed and loaded into the Couchbase engine. Now I'm going to launch this process with this convert script. What we have to see is that it starts loading, and we should see it in the console of this Couchbase installation. So let's just launch. Okay. So on the console, there's a lot of log information in this terminal, and you can see that it's just reading up the logical information first. And once we see ETL process starting, then we can see the increasing number in the bucket itself. So it's already loaded 60,000 records, and it's increasing. The process is using multi-threading, so the number of processors available for this machine, I think it's 8 logical cores. So both of them is busy. And what happens is opening up one by one the unknown files, extracting the data, transforming them from the binary, and put them into a ASCII file. After that, it loads that directly to the Couchbase, and then runs also a finalized script on each and every file. So we finished. We can see that altogether it took a couple of seconds. Successful phase 5, so everything seems to be fine. If we just go back for the file system for a second, I will show you a couple of reports. If we check the etc directory, we can see that a couple of other directories have been created, name always starting with underscore. CM and parser is not particularly important for us because this stands for the parser and the code model. This is the intermediate code model that I mentioned in the beginning of the presentation. The tool stores down the meta information that it can find and it can extract in the physical and logical definition. This is what it's being used in the next process by the data load itself. So it's a universal XML-based model repository that we have here. The output directory is the place for logging. There's a detailed script log. Practically, this is the console information that was running on my SSH when I was running this. If you look inside the start date and the end date, we can see that it took less than a minute for processing the physical logical information, transferring the data, and loading them into the Couchbase engine. Altogether, around 1.5 million. You can see the number of items on the admin console of the Couchbase. Process report is practically a CSV, so you can also open it in an Excel. It's a detailed report step by step about the processes. What kind of processes do we have here? First of all, we have the creation of the structure. Let's call it structure. In our case, it's not a table now. It's just one bucket that we are loading into, so it's not a relational model. Then we have a transformation process. Then we have the load process and the finalize process. The finalize process is practically the counting of the records and matching them against the input numbers. If those don't match, then they are going to be written in an issue report. So the other information that we find in this report is the number of the original ADABAS file, the name of the structure, let's say this way, of the record, and also what happened with this in the open system. If it's a relational model, then it's a master detail relationship there with the normalized schema. It also would be included in here. think it's still worth to check quickly this DB directory. It contains all the shell scripts and commands that are executed during the run. Mainly, we have two type of things here that is run automatically. First is the load itself. The second is the count. Of course, we just invoke this Couchbase import utility with the proper attributes. And after that, after loading each and every unknown file to Couchbase, we also count how many records we did. So practically that's it. There's no additional task with this. Everything is runs automatically, but this directory still holds it. There is one additional thing that we have here called the data. If you remember, I set it to data and load, not pipe load. Data and load means I also physically store down the ASCII files that I'm loading into the Couchbase. Just open it, we can see that this is already the ASCII converted stuff and not the absolute mainframe anymore. So that was the last directory to check. I'm going to quickly check the data a little bit in the admin console. So if we just see the indexes, we can see that a lot of indexes have been created. Both of them are ready. Going to the documents, let's just open one for an example. You can see that there is a type and there is an ID. That's the two key information for us. The type is practically indicating the file name or the record name, or the relational terms, it would be the table name. And ID, this is also something that's inherited. It's coming from the mainframe. This is the ISN of the record. If you are looking at these strange fields, starting with SUP, it stands for super descriptors. It's a specialty of ADABAS. And as you see, we store here binary information, so the hexacode of the descriptor itself. It's questioned whether it's needed or not. And this is one of our practices that we always apply in legacy modernizations in case of the ADABAS and natural. So it can be important for the natural code conversion as well. I have just a bit of time left, so I'm going to speed up a little bit. A short overview of the process besides the ADABAS migration that we have seen. This is even more critical in our projects. This is the application migration. So we have to convert the natural sources, in this case, to Java with the code liberator, and build it, deploy it, and then this application, either in online or batch, should access the Couchbase database. This is what we have. One of the most important parts of this framework to access the Couchbase data is the data access statements in the legacy language. And those have to be properly converted to Java and executed in order to produce the same functions. We have various statements here, also in natural read, find, the histogram statement. And these things cover all CRUD options, so the create, read, update, delete operations in the legacy database. And basically, this is what we reproduce in our DAO layer, which can be an interface for the programs to access the Couchbase database. Those classes implement the operations that the user can transparently access against the Couchbase DB. Just a few words about this data access conversion. The DB-related statements will be familiar for the legacy user, the legacy developers in the converted Java, because they are similar in syntax. The naming conventions and the clauses are practically the same. It means a shortcut for the developer to learn the Java technology and at the same time efficiently code in the converted code base in very short terms. The code is quite straightforward and maintainable. It's quite easy to follow, especially if someone's familiar with the business logic itself. This DAO layer that practically hides the Couchbase database from the developers, it's optimized for performance. So it contains a lot of tricks to do the selects quite fast and the other database operation quite fast on any database. For the end, I just have a couple of examples of legacy user interfaces converted from the mainframe KIX terminal server to the HTML Word. This is a KIX 3270 application now in HTML and JavaScript. Just another one. As you see, this design is absolutely dynamic. It's coming from CSS templates, so it's not dependent on the conversion technology itself. The end users can simply choose whatever design element that they would like to. Testing is one of the most critical items of these projects, either on the database and either on the application side. AppTester, our test automation engine, helps that a bit. Recording test cases on the mainframe and replaying them on the open system in the Java and an automated validation can save a lot of effort and mitigate the risk associated with those quite resource-intensive tasks in the project. What we see here is a dashboard for batch validation. A number of test cases and thousands of files have been validated against each other on the mainframe and in the open system in this case. In online, the testing nature is a little bit different. We are not comparing files, output files, and database content, but rather screen content. On the left, you see a 3270 mainframe screen, and on the right, even if it's very similar and it's black, it's still an HTML page and the online application from the Java. So what AppTester is doing here, it's comparing the content of the different fields and data elements on the screen and validates them against each other. This is another view for the same online test case. We can see some red items on the screen. The content of that certain array is different. So this is what AppTester can do in the online mode. So that was it. Thank you very much for watching. What we have seen is a general approach of FreeSoft for legacy migrations and conversions, and a practical demonstration how a mainframe ADABAS data store can be migrated to the Couchbase with this one-button press automated solution. I hope you found practical and valuable information in this session. And if you have questions, just please free to contact me, and I'm happy to answer. Thanks. Bye.